All right, so let's see here. Yeah, so I think I won. Did I get all the OpenCV stuff done off stream? No, I did not. But I do think we are done today. I think we are that close. So let's finish it off. Let's look at the board. Dewarp and deskew, like there's a version of that that's in here and it works. So that's done. Resizing to 30 pixels. Can't really resize DPI, but I was able to resize to 30 pixels and that did improve quality, so that was good. And then accuracy above 90%. Well, let's talk about that. So here is the current report. Actually, yeah, a little deceptive. I guess on the left up here, without the dewarping logic, here's where the scores stand. So I got 4 test scenarios right now. This first one is in the 80s. This second one is actually performing quite terribly, but that's because it's actually a very bad test. There's only one image that comes through, and so I'm actually even surprised it does this well, that it's almost at 50%. That is kind of impressive. The good one's close to 80. This one's at 86, the shaky leg, which is weird. I thought the good one was going to be the high scoring one, but it's not. Me shaking my leg while taking the images somehow, like I guess maybe I got luck of the draw, got lucky, but those images are good. Now I did just turn on some dewarping logic and shaky leg is up to 89, so it's pretty much at 90. I did actually the other day get it to 90, so something may have changed there, but I'm confident that this morning we will get that in the 90s. Good is at 80. I think that'll also get up close to 90 as well. This one dropped a point. Went up 2 points with dewarping. And then Align Frames crashed. It was in the 80s and it went down. So I think I know what the issue is, but we'll get to that. So the point is, the scores are looking real good. The times are looking terrible. We're at 16 seconds, 15 seconds, and that's running on a GPU locally on a beefy gaming machine. When that runs on the VR headset, these times will be even worse. So really the thing that needs to happen this morning is get these times down, which I'm sure there's some quick wins. I'm sure there's some things I can do that'll really knock these times down. But really, they got to get to like sub 5 seconds, and then the quality is above 90. If I'm above 90% on at least 2 of these, like these 2, if they're both above 90 and our times are below like 5 seconds, run it on the VR headset, make sure that, I don't know, ideally we'd be below 10 seconds on the VR headset. If that's true, we're done with C++, and we'll move back to Godot stuff. I will also add that this will be the last stream for a week or so. So I'm going to take a break from streaming next week. But anyway, so here's what we got to do. I'm going to finish OCR quality. Actually, we're going to finish OpenCV improvements. Let's be done with that. Implement deskew, we did that. Fix image for pixel height, did that. Quick run at performance. I actually did that. I did improve some performance things. I actually did make 2 changes. One that it boosted performance, but at the sake of quality. But it only hurt quality by 1 or 2 percentage points. So not really worried about that. But actually, we are going to focus on performance today. Get performance to roughly 5 seconds? Question mark. Can we do that? Test rearranging step order. Well, we're probably going to do that, right? So as a part of doing some of these things. Actually, I'll leave that on the list. Dewarping, we implemented. We've got some issues. What we need to do is improve letter sharpness in dewarp. Improve letter dewarp sharpness. Let's call it that. So that way it doesn't run too long. All right, that's it. That's what we're working on today. So I think if we fix this, that may really boost the quality up. And if we get up into the mid 90s, I'll be really happy, because then we can make a bunch of performance compromises that'll maybe drop our scores down a bit, but it'll be okay because, there's going to be a trade-off between these two things. So I'm ready for that trade-off. But to make that trade-off the best, it would be really nice if our scores were actually pretty high. Because that'll also make some resilience there, where we could actually do some performance boost things that hurt quality, but because quality is so strong that we may not actually see bad drops in quality, if that makes sense. Right, so Python-m. Is it run? It's just run, right? I can't remember. Let me confirm that. Take a sip here for a second. Okay, we're good. So on the Godot side here, actually one of the improvements I made that involved the test suite was, even though we have 5 images, getting just the middle 3. Because I realized like those outer layers, just, again, this is one of those things this is the thing that boosted performance at the sake of quality. The tests dropped 1 or 2 percentage points, but really it was like those middle 3 images together as a cluster. If, the center image, of course, is the template image. The frame that we capture before it and the frame we capture after it, they're the closest to it, which means they're most likely to align. And if we're able to align those two, well, then the quality is really good. Then do we really need frame 4 and 5, like those next outer layer of the onion frames? And it ended up being like, doesn't really matter. It didn't really affect anything. All right, so the main thing that I think is going to move the needle today is this. So let me run one of the tests. Well, yeah, let's pick one. And let's pick Shaky Leg. I think Shaky Leg is the one. We'll skip building, and then we'll just do -k shaky shack to do the filtering. God, I love this test suite. This is so amazing. That I think is a big deal. So if we can get shaky above 90, I think I know what I'm going to see here if we run that. So let's get the file system up. Yeah, let's drag this in a little bit. So its quality actually went up a little bit, right? So we got to 89. So we went from 86 to 89 by doing dewarping. Now dewarping has a huge performance penalty. So yeah, let's take a look at that. All right, finished. We're at 89, and here is the result. Yeah, so we have, right, just the 3 raw frames now. We're not doing 5 anymore. There's our template frame in the middle. Still doing pretty good on these things, right? That looks good. Well, this one's really important. We're missing the header on both of them, but that's okay. Yep, that all looks good. The boxes look good. Yeah, unfortunately, I'm kind of stuck with this approach, as I mentioned last time. Because we have to crop before we do dewarping. So, what do we end up with? Oh, interesting. So, of the 3, one of them doesn't align, actually. So we end up throwing out this one. How far off is that? That's a little odd. Why do we have this like gray border on the left? Honestly, it looks identical. Right, there's our template. Oh, we're showing the alignment. Okay, sorry, that's why. Because the file we're writing out is the two images merged together so I can see if they're bad. That actually looks perfect. Why are we saying there's poor alignment? In fact, it's pretty nice that you can go up here and see. Ah, well. And this one had good alignment. All right. That's fine. So as long as we got 1-0. So that's interesting. This one's scoring the best of all the tests. And that tells me that, when we grab 3 frames, we just need one of them to align. As long as one of them aligns well. Ooh, that's interesting. So that's a performance optimization we could make. If we get good alignment on one image, we could probably short circuit out and not go do the next one. And that would shave several seconds off of the time. So we go with the first thing we get good alignment on. Okay, so there's our averaging, our enhancing. Here is the dewarping. Now here's what I'm seeing. Look at how that kind of looks kind of junky. But if we look at the rescaled version, here, let's bring that in. Like, rescaled looks pretty good, right? Oh, we got some like stretching at the top there. Oh, because of the thing. Yeah. But like this is quite readable, right? The word like whenever here. That's a pretty readable whenever. And then when we do the dewarping with the binarization, there's binarization as a result here. We get like a pretty rough. Let's go tight on that. Yeah, look at the H. We lose that connection there. So I think the issue here, and so yes, this helped quality for this one, but I think this is why the quality is not as good as it could be. Like why we're not scoring into the 90s. So I think the solution there is this. So smooth and noise blur. So our Gaussian blur, where are we doing our Gaussian blur? Here's Gaussian blur. I don't think this is the one we're using though. I got some old prototype code in here that I need to throw away. I don't think it's this one either. Oh, you know what? I think when I brought in the dewarper, it started doing like its own Gaussian blur. Yeah, okay. Yeah, it's doing all these extra steps here that I don't love. Like I'd rather these be done. I gotta pull these out and add them as part of the enhancer. Like the dewarper is doing too much, and that's probably also performance boost too. Like we don't really need to do all these things. Okay, so the question would be, so this article specifically is talking about improving for text. So he's saying I like combining Gaussian blur and median blurs for smooth noise reduction while keeping text contours intact. So saying doing a Gaussian blur, a 330. All right, let's copy this. Just yes, it's always backed up in Git, but might as well back it up here. So if I just switch this to a 330, I don't really know what those settings mean, but does that improve things? We cannot skip the build anymore since now we're making code changes, so we have to rebuild the C++ library. That's going to take a moment. And then while we're doing that, what is medium blur? Am I using that anywhere already? Yeah, it should have the same naming convention. I am. Here is a medium blur right here. Apply single frame enhancement. So here we were doing medium blur and then, okay, and then this. Okay. I guess that's denoising, right? So if I bring that in here, so there's our blurred and our denoised. And he's saying also does a 3. So I already had it at a 3. $90. Okay. So that did improve things just by changing the Gaussian blur a little bit. I think we went up a point. Really, nothing special. So we have our denoised version. Oh, yeah. Before I move on, excuse me. Let's take a look at that result. Did we get a slightly better image? And I'll use this whenever as a hint. Slightly, I guess, which maybe is why we did slightly better on the performance. Okay, so if we do the blur and then we do a denoise layer and then we do binarization, where we're going to do binary plus Atsu. How does that do? Whoop. Oh, I was going to say, I thought we did a -S. It's like, nope, didn't do that. I wouldn't be surprised at all if this alone incredibly boosts things. Now also, I did make a tweak. I would very much like this to be white, this outer area. So maybe, I think that's a setting. I can tell this to be white when we do the binarization. I'm not sure. So if I go out to the test results and we look here, let's not even look at the score. Let's just look at the image and then let's predict if we think the score is going to be better. Okay, I am seeing no difference. And the score is the same. So that didn't have an impact. Bilateral filters are another technique for edge-aware smoothing. They have higher computational cost, but best balance detail retention for OCR. How to use image processing to improve accuracy in Tesseract. Okay. Yeah. Broken images, so I can't even see. Notice how the second image. What second image? Okay, so resizing. I did the resizing actually. I completely forgot about this article until I came back to it, when I had already had this on my to-do list, because if we go look at, let's bring this up because this is the one we care about. This is all the research that I had done for what things might help us. So actually, how are we on the pipeline? So detect text, we did that. Bounding box, did that. Crop down to the two largest B boxes, which we did. So that's how we got page 1, page 2. Merge, blend multiple frames, doing that. Dewarp and deskew is happening sooner. Yeah, sure. Apply some denoise and contrast. This is the other thing I'm going to try to see if we do this before dewarping. Does that improve things? Custom binarization, yes, we're doing that. Gaussian plus Atsu. Rescaling we are doing. And then I haven't turned off binarization yet. I don't know if that's going to matter. But that also could, in theory, that could produce a performance boost if Tesseract is doing it every time anyway, and it's not smart enough to detect that the image already is black and white. Turning that off may improve things in some way. All right, let's keep at it. So, resizing, sure. This transformed the image so capital letter heights are about 30 to 35 pixels. See, I think interesting, he has like image height, scaling factor is image height divided by height. But that's the image shape. So your image height, how are you factoring that? For already high resolutions, we may instead want to shrink content to remove noise. Inter-area resampling prevents quality degradation during downsizing. Okay, so smoothing, noise, and blur. So this is what you're saying, is doing those two things. And I did them, and nothing improved. Color image is a crisp black and white. This is useful as Tesseract may mainly recognize binary text endpoints. A simple image-wide thresholding method is there. But this fails for unevenly lit images. Adaptive thresholding calculates dynamic across. The Atsu method computes the optimal global threshold. This is what I ended up actually basically implementing exactly this. So you're saying threshold my images. I mean, this is the Python version, not the C++ version, so I have an extra argument for the output. Okay, so you're doing binary plus Atsu. Here's a comparison of these approaches. Okay, well, I can't see that. Let's give a shot to adaptive. Comment out the old one, and we bring in blurred, and then we have binary, and then we should be able to do that and that, and then cap it off. And I think that's all that's needed to convert. I mean, didn't break so far. Okay, so we got to 90. Let's go and let's up our results here, right? We expect to get to 90. I think our good scenario went to 79, I think. And then align frames crashed down to like the 60s, right? And then the align frame crop, that I think went up to like 46 or something. I think they all went up by like 2 or so, except for align frames. Ooh, 38. Okay, how's that look? What did we get? Yeah, lots of noise. So we'll switch back. I mean, I was pretty sure. I mean, just looking at OpenCV's docs, binary plus Atsu, and you get that perfectly crisp black and white image. Now, let me take a look here. Why are we getting what we're getting? Here's our final image. We've cropped out crossing the chasm, so we've lost something there. Can we get that back? See, here we have it here. And then our bounding box. What if we fix that? Think about how I looked for padding, right? What if we switch this to like 40 pixels? Just let it go a little bit bigger. A little more generous. And we'll get ourselves back to the regular one. Okay, so this article isn't really helping me. De-skewing crooked scans. Heavily slanted documents. You know, and then I did test like vanilla de-skewing. That's what I built on Monday. The logic for that wasn't good. I used Claude, and what it generated, it wasn't good. I think it was making some assumptions about my data because it didn't fully understand the kind of data I had. So I had to throw it away. But in theory, if I manually, like I made some manual tweaks to the de-skewing to get it to work for the one test scenario. And I think that did put us up into the 90s as well. Which might be worth revisiting for performance sake. We may be in a place where, hey, maybe we just do de-skew and not de-warp. And is that good enough? I like this article. It's useful. But like your medium blur isn't helping. Okay, we're back to 90. Did that at least get us more text, maybe? Slightly? Okay, yeah, it did. What about earlier in the process? Where's our template? Okay, yeah, our template, yeah, now we barely get it. Which is fine. You know, it's good to be a little more generous on it. And it doesn't really cost us anything. I think we're kind of a little bit starting to get the text from the next page over, but I think that's okay. Now, when I looked at this, okay, so that's fine. We'll leave that as that. This I don't think is needed. We'll trash that, but I'll come back later and clean things up. Oh yeah, so what if we try... Let's just experiment a little bit. Again, my throat. Let's trash out Atsu. And let's see what that looks like. OpenCV C++ docs. Uh, 4.1.3. Let's go 4.12. I think we're actually on 4.11, but no, you know what? Let's go with the dev version. That way, if there's like something new coming up that I don't have access to, we can see it. And then we'll look up thresholding. Like, what are our options here? CV threshold. Here we go. So input output. Double is the threshold. and then the max value. Okay. I wonder if we change this threshold, like what's going to happen. Score of 0. Can't catch a break, can we? Yeah. Well, that was bad. Yeah, this is why I also don't like doing this here, is because I can't print out these images and see, like, what does this look like? Because what I'd like to be able to do is, like, tweak these individually and take a, and, you know, see what I see. Let me see here. If I come back over here, was this my... No, that's previous score results. That is not what I was looking for. Oh, so it is this. Do I have this file here? Hold on. Oh, no. It's not going to be here. It is going to be somewhere else, right? Hold on. Let me see here. What's interesting, what method are we in here? Remap the image. Oh, you know what? Let me just pop this up here. There we go. Okay, so this was in here. This was the prototyped version from Python. And that was this. So the original version was adaptive thresholding, but it just did see, when I translated this over, let me see here. Was it this one? The fixes warping. Create a C++ version. Okay, here we go. What was the vanilla version before I started messing with things? Because I started making a bunch of changes. By the way, this is literally the bottom of the file. Okay, good. Interesting. I somehow threw this away. Okay, so yeah, so it was like that kind of version. Yeah, adaptive thresholding C, binary. Okay, so that was... How did I kind of lose that? And then what is adaptive WinSZ? Is that a thing? Okay, using adaptive thresholding here as well. Interesting. But that's binary. Okay, this one's just doesn't work. That's fine. I don't know. I don't think Atsu on its own would do well. I want to try that again. But then what else do we have here? Huh. I don't remember bringing in the blurring Gaussian. I guess maybe I did bring in the Gaussian blur. Okay, so that was all me then. Okay. That makes sense. All clear now. Let's go back to the vanilla version of this. I don't think it's going to be as good. I think bringing in Gaussian blur was a smart move. So if we take remapped... Okay, yeah, so that was... Remapped was what it was. Do we somehow magically get above 90? I'm gonna guess no. And I am curious what it looks like. $75. Why is this not scrolling? Yeah, so we end up with these other artifacts here. But the question is, can we tweak that and get better results? So how does that work? If I go down to like 5 here and rerun it. So that took us down to like 75. Like, what does that do? And where is our OpenCV docs on this? So we have our input output, max value, the method, threshold type, C. Okay. Constant subtracted from the mean or weighted mean. Normally it is positive, but maybe 0 or negative as well. Threshold type can either be binary, binary inverse, Adaptive method. Border isolated. $42. We've made things worse. That did, in fact, make things worse. So what if we go the other direction? Instead of 25, what if we go like 45? And then I'd be curious if we brought back in blur and noise into the mix. Although again, I think what I could probably do is steps like this, I could do them before we even call the dewarper. So up until this point, you know, we've done all of our cropping, we've got our multiple images. We then call this, which is a pretty beefy method if I recall. And that does the merging, that does the aligning of the frames. So we end up with a single frame. Then we figure out the capital letter height and rescale. We might want to do this last. If we do this, the later we do this, the faster it's going to be, I think. 87. Interesting. So we're back to the same ballpark of quality. And more importantly, like the H here looks pretty good. I do kind of like this more. I hate how clicking in causes you to jump all the way up. Oh, darn it, I lost my place. Here we are. So what if we bring back our blur? And set that in here. Mind you, there is one test scenario that we don't have that I probably should go get today, which is natural lighting. I think all the test scenarios I have, I turned on bright lights in the room to make sure I got a good quality image to start. But that could change things, especially on this code that we're looking at right now, where the adaptive threshold, or you know, where it's going to have trouble with shadows, or just lighting that's not as obvious. 84 made things worse. Interesting. I do think that did an okay job at cleaning things up a bit. I mean, this is starting to look, again, back to perfectly crisp. I think it's just a bit too strong. So can we... Again, I click there. It's so annoying. Okay. Can we turn it down a bit? I think previously this one got us a performance boost. So if we go with that, what does that do to us? $90. So we're at 90 again. Now the blurring, what does that really do? All right, let's do this. Let's comment this out. Let's bring remapped back in. What happens if I pull this out to a higher level? Can I do that? Where am I? Okay, yeah. Here we are. So if I put that there, and what are we going to take in? We'll take in rescaled. We'll take blurred. And we'll send blurred into our new step. And just on the off chance that this works, let's save our debug image. Happy? Good. And do we still hit 90? If we hit 90, this is good, because then I can look at that blurred image and see if I can tune this to figure out like what's going to look right. While that runs for a second, don't I have other articles here that helped me? Another problem. 85. So no, it didn't do the same thing. I guess because there's the de-warping steps do a bunch of things. I don't know, looks pretty samey to me. So I don't know why it wasn't 90. But we have our blurred image, right? So it actually does blurring. Why would we want to do any blurring at all? How does blurring help anything? Feels like it doesn't. Because we're going to lose the crispness of letters. That's what it seems like to me. But okay, let's do this. Let's pull things out of here and not do it here. We should be able to do denoising as well. I might be able to just straight up do a denoise. So if we just do the denoise without blurring, that may help quite a bit. What did we score? 88. Interesting. So that helped. And I think it helped because I think it kind of had less of an effect. By the way, what does Gaussian blur do anyway? CV, Gaussian blur, source output, the size is the third argument. Yep. Sigma, I guess it's sigma x. Border type algorithm hint. K size. Kernel size. Width, height can differ, but they both must be positive and odd. How odd. Or they can be zeros, and then they are computed from sigma. Standard deviation in the x direction. If 0, it is set to be equal to x. If they're both 0, we compute it from k size. Border type. Hint. Implementation modification flags. See algorithm hint. Use generic portable implementation. Allow for faster implementation. Behavior results depend on a platform. All right. What did I see here? Right. Let's try ditching blurred for a moment. And let's do denoise. And while we're at it, let's save off an image so we can see what happens. So we're still just generally flirting around 90. Not yet seeing anything that's really going to move the needle. Threshold with mask. What is this? Threshold, right. Did I ever end up using any of this? Soft float. Okay. 87. Still not moving the needle. But I do want to see what this looks like. So let's bring that up, and then let's bring this up. And then we can drag this over, pick that. See, when we denoise, we do lose some things. What if we change the threshold of it? While I run that, let's look at denoising. Oh, also I have my old cat, like this I've been keeping around for a while for reasons. I think some of this actually worked pretty well, if I recall. That's interesting. All right, let's get back up to 15. There we are. So we could try this method as well. that is that. Comment this out for a second. What's our result? 87 still. So going to 1 had no effect, but visually does it have an effect? If I bring up the denoised image, let that float over there. Let's go get the next one. So this is the newest one. Okay, it just didn't denoise it as much is really what happened. So it's the strength of denoising, which is what I thought that would be. If I crank that up to 5, and it seems to have no effect on OCR, which is okay. So I'll give this a quick run. I just expect it's going to make things terrible, and then we'll try the other approach for denoising. Yep, there we go. We reduced all the noise. And we end up with garbage. We'll get a score like 0. 41. I'm surprised that we got that, even that. All right, so this, I don't know. It could be 2. Originally set to 3. 2 might do something, right? Because like 1 did nothing. 3 I felt was doing a little too much. But let's give this a shot. Our fast denoising. Because again, if we can successfully clean up the image just a little bit, then when we do these other steps, things should be better. And how is this looking? Oh. Wrong input type. I think that's because enhanced. What does enhanced do? See, this has a contrast and sharpening step. So maybe I should be messing there instead of somewhere else. Right. Averaged is color, enhanced is black and white. Averaged, enhanced. Gotcha, so it is this enhanced. And then dewarper does a color underscore step, right? RGB to gray. What happens if I just do that real quick? Or better yet, let's ditch this here. We'll pass rescaled in there. And then let's take this over to where we probably should be doing things. Right here in this step. So we average and we enhance. That's pretty good enhancement. We just have like the noise around it, right? So what if I put this here? Oh, it's colored. Is there a non-colored version of it? Here. You know what? I'm not going to bother keeping these up because Lord knows I just will never go back to them and I'll search for it anyway. Actually, if I search for that, yeah, so that's a thing. Fine. There's one easy way to find out. Actually, let's do that. We can do this, right? Yeah, fine. Denoised. Right, so this is why I need the docs. Where are you? Probably this one. Fast N1 means denoising. Yes. Input, output. Our vector 1, 2, 3, 4. Yeah, what do you mean overloading? I don't know what you're talking about. Argument types are mat, and then 4 integers. No instance of overloaded function matches the argument list. Okay, well, what if I do this? So this is saying, per the docs, input output float, which defaults to 3. So in theory, this should be 3.0f. What else? That's so funny that like it's literally the defaults. So 3, well, no, then 7, and then 21. That's too funny. So I guess the extra argument here is just not used. Okay, well, let's return that instead. And we'll run that. We did clean this up, right? Rescaled gets passed in. Dewarped is what we OCR. So just so we see here, this is the old enhanced. And we'll look at the new one. This is the new enhanced. And we will put them side by side and zoom in on this word. They look the same to me. It's as if we did nothing. Huh. By the way, I literally did just mess with these things, like this method the other day, yesterday, I think. And I did improve things. Like I tuned it as much as I could to improve things. We're just not denoising. Okay, what if crazy idea. What if we denoise it first? And we do it on color, which is probably performantly worse. But we denoise it. Because I'm pretty sure this did something. If given a choice, I don't want to denoise color. I mean, I'd rather... Why can't we just make things black and white and then go from there, from the beginning? That'll probably boost performance. So we probably have to do that at some point. I'm just not getting the quality out that I wanted. Well, it did something, I'll tell you that. Is that going to actually improve anything? I mean, I got rid of like the noise in between things. 90. So source, destination, H, parameter regulating filter strength for luminance component. Bigger H value perfectly removes noise, but also removes image details. Template window size in pixels of the template patch that is used to compute weights. Should be odd. Recommended value 7 pixels. Search window. To compute the weighted average for given pixels. Should be odd. Affect performance linearly. Greater value, greater denoising time. Recommended value of 21. H color. Same as H, but for color component. For most images, value equal to 10 will be enough to remove color noise and do not distort colors. So 3, 3. Go with 13. Add 10 to it. What does that get us? While that runs, I know there was an article somewhere that I had found that I felt like helped me immensely. This is a research paper. This wasn't it. I don't need to blend images in Python. Godot's image class. Oh yeah, right. This was like a Godot shader for blending, but I don't need to do any of this. I'm not doing it on the Godot side anyway. I'm doing this in C++. What is this? Debugging? Debugging tools. 65 is the score. Let's see what it did. So if we go to like 7, instead of 3, let's go 7, 7. And again, just let it run while I continue to do my searching. Okay, so this is that article. I don't think any of this was useful. I don't remember why I had this up, but I know I had it up for a reason. Hybrid apps. $88. So that actually kind of, sort of helped. Yeah, actually. Well, what happens when we binarize it? Is sort of the question. Hey, I feel like we're getting some ease in there. Okay, what if we take the color side to 10? Let's take them both to 10. The Android platform has numerous APIs. Godot is provided. Okay. Godot testing libraries. Yeah, I ended up looking into this briefly, and I ended up kind of rolling my own testing library. I'll probably revisit this at some point. But I'm very happy with my test runner. It does all the things I wanted to do. $81. So it got worse. Kind of expected that. Yeah, it went a bit too tight. And then when we binarized, we started losing things. What if we back off here and just the color channel? Drive that higher. All right, was there another doc somewhere? I don't think I ever used this. I don't think I need to care about that anymore. 404 not found. Interesting. Yeah, I don't think I'm not going to use this. Okay. Where did this end up? 89. So that's interesting. So we're back up towards around 90. That's starting to look more like what I want. Still kind of frustrating. Where was that I saw that? It was something about... Splashing some water. Maybe it was on my laptop where I was doing research. But it was something about improving the crispness and definition around characters, and it wasn't this article here. It was somewhere else. All right. So what if we like take that to 15, take that to 7, and run that nonsense while I pop open my laptop and look at the copious amounts of research I had on here and see if I can find this article. And if I can, I'll pull it over, of course. Yeah, so we're still at 89, not really moving the needle in any meaningful way. I mean, the E looks pretty good there. I like that. The W also is okay. Let's see here. So that's like the D-warp research. I don't have any research over here. Nope. And it wasn't over here. All right, so it's definitely not on this computer. Didn't want you to do that. Okay. So yeah, there's some improvements to dewarping that I had found. Right, so this is all dewarping research. Not what I'm looking for. Okay, and then what else we got here? Yeah, other research. I really gotta clean these things up. Let's see. This might be useful. I think this was an older article. Not what I was looking for. Let's see, code snippet. API stuff. This is like a whole bunch of research on Tesseract page segmentation modes, which I had fixed that, right? And that actually had produced a big result for me. Didn't I? Let me confirm that. Yeah. We're now using 6. 6 is the one we're using. Okay. That's all fine and dandy. There's a chance it was on my phone. Ah, so annoying. One more moment. See if I can find this. All right, I'm going to say it's not on the laptop. And let me take a brief look on my phone to see if I can find it. I really feel like I just seen it the other day. All right, I'm gonna say it. If I have it, it's not someplace obvious. Or maybe it's something I closed. All right, let's get back to trying to figure this out on our end then. I mean, I do know, again, the core... Oh, you know what? It should be here, right? It's probably, I didn't go far enough on my tab here, so it probably is right here. So what does Tesseract say in terms of improving quality themselves? So they say inverting images, we don't need to do that. Rescaling, binarization, but you can see the issues here with binarization. We get the artifacts. So remove noise. We're doing that. Yes, this is, okay. It was not a tab or an article I was reading. I was accessing my brain, and my brain was telling me erosion. I was remembering this from Tesseract's docs. So this doesn't seem to have much of an effect, right? So we have our input image. $89. I think the quality might drop here, and if it does, simply switching back to Atsu thresholding might actually just get us back up. So let's just try that with possibly like a simple Gaussian blur. So we are at 89. In theory, this hurts us, or maybe it doesn't. 87. And if I switch back to this, so again, we're still just like dancing around 87 to 90 is where we've been. Not really moving the needle much at all. And I keep saying moving the needle. Let me just quickly see if I undo some of these changes, do we get back to like 90 but from a different way? 83. But if I do this, that takes remapped, we get blurred, and we pass blurred in. Oops. And now I wonder, and while I'm at it, I'll do some cleanup here real quick. So what, 7.9? We've done a lot of things in 7.9 here. Go down to here and just delete those. What was it, 11.27? Not this one, right? Should be a new one. There's 11.28. $90. So we got back to 90. Again, I don't love some things like these letter E's, but I guess, I don't know, in the process of fixing those, something else probably got worse. So it seems to like this better. I don't know what to tell you. Okay, so bold characters or thin characters, especially those with serifs, may impact their recognition. Yeah, I want to get rid of serifs. And reduce recognition accuracy. Many image processing programs allow dilation and erosion of edges of characters against a common background to dilate or grow in size. Dilation or shrink. Erosion. Heavy ink bleeding from historical documents can be compensated for by using an erosion technique. Erosion can be used to shrink characters back to their normal glyph structure. For example, GIMP's value propagate filter can create erosion of extra bold historical fonts by reducing the lower threshold value. So we've got the original here. I'm kind of seeing some of this. Erosion applied. And this article goes to, okay, the math behind dilation and erosion. I have C++ code that implements OpenCV on matte images. How do I apply dilation or erosion to remove serifs from text on a book page that we have an image of? This functionality is undergoing temporary maintenance, and yet it still works. To remove serifs from text in OpenCV, you'll want to use erosion rather than dilation. Erosion shrinks white regions and can effectively remove thin projections that makes up serifs. Key points for serif removal. Why erosion works. Serifs are thin. Yeah. Okay. Before we run that, let's do -s and just see what's our new baseline for all of our quality before we embark on this. Yeah, I think we got to 90 here. I want to say that this one's going to get like 79. .72, so line frames have gotten worse. But not as worse as it was. I think it was in the 60s before, so now it's... Yeah. 46. What is this, 76? I don't want to reduce the number, but for now I will. This is going to be 79 probably. Oh. 87. Right, because dewarping greatly improved that one. 90, 87, 46, and 72. Okay, so what are you saying? Kernel selection. Using rectangular kernels, morph rect, rather than elliptical ones. Start with small kernels to avoid over-eroding. Experiment with kernel size based on your serif thickness. Process refinement. Quick but may make text too thin. Remove serifs but restores some character thickness. Opening operation. Combines erosion followed by dilation in one step. Oh, interesting. Ensure a good binarization first. Otsu thresholding usually works well. Interesting. Okay, so you're saying binarize first and then do this. But if we binarize, doesn't that kind of ditch things? I would think we would want to, All right, so you've got your book mat, blah, blah, blah. We pass our method. That's fine. You're doing some things I don't care about. Remove serifs better. Okay, so you've got two methods here. Remove serifs. Convert to grayscale if needed. And then interesting you're using the pipe character. Threshold to binary, white text on black background. Create a small rectangular kernel. Apply erosion to remove serifs. So it's really just these two lines of code that I care about. And then down here, convert to grayscale, do our binarization. By the way, CV, what is it? CV threshold. What are we doing? CV threshold does the pipe. Does that matter at all? So that, I mean, I was already doing that. I assume the pipe has 0 impact, but let's just confirm. It's possible it breaks things. Oh, you can highlight and say improve. That's cool. All right, so this one, we're doing the same thing. Thresholding, we get our kernel. This one's getting a bigger kernel. We then erode by the same amount. And then we use dilation to restore some character thickness. Okay, I think it's really these steps here. So I'm going to experiment with this right here in this file and then abstract things out later into the camera enhancer if I need to. So this did the de-warping. Let's plop this here. And we'll call this like remove serifs. So we have our de-warp, and then we're going to have our matte eroded. And then we'll have our matte dilated? Sure. Let's call it dilated. And then after each one, I'll drop an image. So we can see visually what it's doing. And then finally, our dilated gets passed through so we can see the score. By the way, did that change anything? Whoa! It did. Kinda? Oh, never mind. No, it didn't. 72, 46, 87, 90. I just saw that one of them wasn't failing, and that's because I put my finger on the scale and gave it permission to score worse. So it did the exact same. Okay, so doing the pipe operator is the same as doing the addition in that case. All right, fair enough. All right, so we have this. Let's run this on our... Ooh. Oops. Darn. I was skipping there. That's fine. I'll be able to verify it anyway. I'll keep it in the back of my mind, make sure I check for it. And that's it. That's all it's saying. So that's all we have to do. That's how you do erosion. cv.erode, cv.dilate. You create a kernel. We can tweak the size. That's going to help things. All right. But does it do what I want it to do? Okay, so this is de-warped. That's eroded. Interesting. And then this is dilated. Things scored worse. As expected. I will, as a reminder, let's just switch that back, just so I'm not accidentally confusing things. Okay, so what if we just skip dilation for the moment? Dilation's technically optional. And then let's erode. And let's go smaller on our size, because I feel like it's way too much. Because we had these two images. feel like that's just going to make things worse. Like you look here, it's like, just makes things chunkier. And this does have serifs, right? Yeah, it's a serifed font in this book. I fail to see how that's going to help things. 87 though, so that helped. Helped in that we are undoing what we did. Okay, so we went smaller there. What if we bring back the dilation? Can't help but feel like I'm spinning my wheels here. So what else you got for us? Interesting that the erosion doesn't seem to be should the erosion, I think this is wrong. I think this is backward. That's what I think is happening. Should the erosion be making the text bolder? Because it is. I don't think it's supposed to. No! Erosion should not be making the text bolder. It should be making it thinner. It's likely have inverted binary value. Here's the corrected code. The key change is thresh binary inverse instead of thresh binary. No? Text becomes white. Huh? If you want to keep the original pull... What? No, this doesn't sound... This sounds dumb. It sounds like you don't know what you're doing. 88. So actually that did kind of help things a little bit. All right, let's turn on our brain and let's experiment. So yeah, that made things bolder. Let's not make things bolder. That's gonna be bad. What if we change this to, okay. Let's look at RTFM. Read the manual. Erode. Erodes the source image using the specified structuring element that determines the shape. Kernel. Kernel's fine. Anchor. Position of the anchor within the element. Default value is -1, 1, meaning that the anchor is at the element center. Number of times to erode. Okay, I thought making that -1, -1. All right, there's a chance that Claude knows what it's doing. But I don't like that. So you're going to do a binary inverse, which is going to muck things up. Huh. I assume dewarping will be okay, but it might not be. That'll still be fun. You know what? Let's just do the inverse. Let's see what happens. It's probably not going to end well. But what Claude's saying is should be able to do a invert the, yeah, basically invert the image. Because we're going to do a bitwise knot, which is going to make everything black, white, and everything white, black. It's just going to flip all the bits. So I'll keep that in my back pocket. But it's saying, yeah, do the same thresholding. Where are we? Do the same erosion. And then do the same dilation. Quality dropped quite a bit. Yeah, and we've so we inverted the image. We dilated it. So that's true. That did work. Okay, so one moment, please. Let's undo that change. And let's take our dewarp. Let's move this up to here. Let's do dewarping sooner. And then we'll take dewarped and we will pass it in there. And then we'll take rescaled and we'll pass it in there. If we just do it sooner, or I guess put another way, rescaling should be the last thing we do. Because it shouldn't matter. Rescaling shouldn't affect anything other than performance. Rescaling is going to hurt performance. So let's change that to rescaled. And then what you're getting passed in is dilated. And then dewarping. Okay, so now what we're doing then is we're merging all the frames together and doing some improvements there. I really want to break this out into multiple steps because then I can reorder these things much more easily here in business logic. We are then going to dewarp and deskew. And then we're going to remove our serifs once everything's flat. That feels right. And then we'll rescale. Rescaling will be the last thing we do right before we ship it off, which means we can do this inversion here. And we will have to do another CV mat. Inverted. I guess you could do the operation. I don't know. I like passing these through so I can investigate things. This is our result. Here's our result. There's our result. And what we get in is dilated, right? Oops. Here. Oh, but one step I did was I undid the inversion. What if we just pass dewarp to it for the moment? So I can see the output of these images, but I want to make sure the score is fine because I moved things around. Yeah. Yeah. Okay. Rotation deskewing. So fixing skew. Borders. Yeah, it does want a border. That's something I want to fix. Okay, so really it's just this. This is the only thing I care about for the moment. 86. Did that make things worse? That may have made things worse, actually. Interesting. Oh, well, of course, that's going to be a problem. But if we invert it... okay. I think I broke things. That's okay. Let's go with this. It's just... Let's run it, see what ends up happening. Let's take inverted and pass it in. I think I boosted speed though, right? Probably. I can't tell. So it made things worse because who knows, maybe dewarp and deskew performs better after it's been rescaled because a bigger image is easier to fix. God, this is frustrating. I was hoping to see, as is always the case, it seems like I go on stream and the things I tried don't really bear much fruit. And then later I take another attempt and I fix everything. So here's our inverted text. And everything got worse. So let's look at our diff. What do we have in our code changes? So this was a bug fix that actually improved things because I was passing the wrong thing in. We don't rescale, we dewarp. Remove serifs. Rescale. I did add some padding, which should have been fine. We did switch our Gaussian blur to a different value. And we did get rid, okay. I wonder if we switch this back, if that's going to have some sort of positive impact. And then for this, let's just look at the image, shall we? It's going to be hard to see because we've inverted things, but it should be fine. So, we thinned things out quite a bit. So we lost a lot of definition. Perhaps too much. And then when we bulked it up again, yeah, everything's all pixelated. That made things worse. Yeah, we are definitely going in the wrong direction. So I think this was like an easy performance win here. That. So let's just leave that there. If we go 1-1, does that make things better or worse? And testing all this is so much faster now with the test harness. It's already paid off in spades, I think. I think it would be much harder to test all these changes if I didn't have this. 86. So if we have it here, '86, huh? Now, if we skip it all together, and we pass D-warped into there, and then we come back here, and we change our method back. So if we just don't do it at all, what do we get? Interesting that erosion I mean, instead of having to invert, I should just be able to do dilation then, and just be like, hey, look, actually, because we're inverted, dilation is erosion. Then I don't have to flip things and I can see stuff easier. 86. I mean, I think that was literally the same score as before. What if we don't do dewarp deskew? I don't know if that's going to improve anything. $86, same score. So like this is what we end up passing in, and the rotation on it's bad, and it does just as fine. Okay, so, oh, okay, well, how about that? What if we don't do dewarp, but if we do erosion, it needs to be inverted, right? Because we didn't do binarization. What if we just did... What if we literally just did these steps? Simple, I just do binarization. So we take our enhanced image. Yeah, let's we got blurred, we got binary, we take binary, and we rescale it. I know dewarping and deskewing improves things, but we've lost something in our approach here. Like when we're doing our binarization, when we're doing our denoising, our dilating, our eroding, we are losing data, and it's hurting our performance in Tesseract. $84, huh? Interesting that stuck around there. And we know we got some weird quality issues, but the fact that that is getting an 84 is interesting. And how do these even look? So there's enhanced. What happens when we erode it? I don't think eroding did anything. Enhanced, eroded. Yeah, because I think you need to do binarization first. So here, let's give it a whirl. So this is then just skipping dewarping, binarization with erosion. Does that improve things? It's one of those things, like, I know, like, I just wish it would happen on stream instead of on my own, but I know, like, I will have a breakthrough moment where all of a sudden, like, I am getting rid of the noise, I'm getting rid of the serifs, but I'm keeping the rest of the data. Because, like, things like the letter E, the bottom curl on the letter E is good data, right? We want to keep that. But you want to get rid of, like, the serifs. So, I don't know. Ew, gross. What? Oh, right. The fact that that did an 84 is actually pretty impressive, all things considered. What did I do? Enhanced, blurred it. This will most certainly improve quality, because Tesseract doesn't like the inverted image. Is there anything salvageable? Can I even see anything in here? Also, I don't know what happened with this. That shouldn't be there at all. Still 84. Interesting. So this is what we sent in. You know, I will say anecdotally, I think it does have less serifs. If we go back in time to the beginning of the day, this is dewarp, deskewed, and then there's the word selling. Here, let's go. Let's go all the way out. So this version is pretty good. We got rid of this here. We go in tighter. Yeah, we can see it lost some things. that we got back. I don't know. The word M here isn't as good as this one here. But this commit is bad. This commit is better. This hole is bad. This hole is better. Here we go. The selling. Yeah, we got a little bit more of the E here. So I think overall, and like it doesn't have the L, the L's don't have the serifs really on them. So I think overall this was better. Look at that I. That I is a little bit more straight, a little bit less garbage on it. The N as well. It's a bit cleaner of an N. So I could see heck, if we grab this, come down here, and ran this step. I wouldn't be surprised. Again, the process, obviously, like we're doing like the same step multiple times in a row, so these are things that can definitely going to hurt performance, but that's easy to clean up later. This should just take what we just did and rotate it, and I wonder if we see a heavy boost in performance as a result. I was expecting this morning that I would move much faster on improving quality and then immediately move right into speed. 81, it made it worse. Interesting. I mean, that is what it was, although again, we've lost some things here. And that got well, I guess because we're doing binarization twice, and because we already binarized, we don't get any of the benefits of earlier steps that happen here. What if we turn this back on? Here's an idea. I'm going to leave these here for now, but what we're going to do is let's just return remapped. Like, why are we even doing this here anyway? This shouldn't be done in this file at all. We've already basically moved it out. So we get our D warped. And then we do our blur and our binarization up here. Do them outside. But still get the benefit of the de-warping, which then we can see, and hey, we get the one benefit that I've been asking for a little bit here. Sorry, that's binary. This is blurred. So we collapse the images and make improvements to them. We de-warp. We blur, we binarize, and inverted binarization. And then we take that, we erode it, we dilate it, we invert it. Yeah. How does that look? And well, if nothing else, will I see interesting images that tell me something new that I didn't already know? This is kind of weird. Oh, right, because this is that's the thing, right? This is the thing. And this is why we're getting this artifact up here. Dewarped got done, but it didn't get used? Huh? What? Oh, darn it. I walked through it looking for the thing to fix, and I didn't find it. Okay. So we dewarped, but we didn't blur the dewarping. Instead, we just did the thing we did before. And then that shadow stuck around. Somehow I was cleaning that up before. I don't know how. But I think we're missing a step, and that's going to hurt quality. So the fact that we're not cleaning that up, because we did have that cleaned up, right? 86. So we got slightly better results. If we go back to the beginning of the day, yeah, that was getting cleaned up. I wonder if that's adaptive. I mean, I guess the beginning of, well, if we go back to yesterday. There's some noise there. We did clean up that noise a bit. We've lost some definition though. We've squashed some things. I don't know. Something's a little off. 86. Why do we have another binary here? Blurred and then binary? Yes. But shouldn't the... Yeah, blurred. Maybe we don't blur things. Wait, no. Let's get rid of the blurring. Let's just not do that step. Go straight to binarization. is kind of frustrating. So we started off today. Maybe I'll just keep it up. Like, this is what we had when we started today. And this, I think, was scoring a 90. That's our 90 score. And the thing I didn't like about it is we were losing some data. All right, got worse. We got an 80. Interesting that we've got like artifacts in here. If I go back to the beginning of the day, dwarp dskew was doing the binarization. You know what it could be? Oh, went back too far. Okay, enhanced image comes in here. Nope, we need to take dewarped and blur it. But let's go back to this one. I think this is what we started the day with. I wonder if that... Yeah. In theory, if we binarize, and then we take our result, and we don't erode, and we don't dilate, and we don't flip it, '81. It's fine. If I run that now, does this get us back to earlier today? I think the other thing is, again, rescaling. I moved this to happen later, because that does improve quality. And it boosts, by doing this later, things get faster, because we want to work with smaller things. Okay, I think what I probably need to do is effectively just like reset myself back to what was working before. And then now that I've learned a bit, yeah, it's still 81. What does that look like? Very frustrating. If we compare to this, this is what we had going into today. Here's what we have now. What's interesting is like that 2 is very thin. This one's a little chunkier. So in many ways, this 2 is better. This put is better. Here's why. This development has some brokenness to it. This one doesn't. the R in reference here is better than the R in reference here, because that's almost like an R and I. So we made things better. But we've got this noise here, which should be gone. And we broke some things down here that looks worse, I think. Yeah, like focused down here looks worse than that one. We had this tearing up here, but that's because I fixed the cropping. Okay, I think what I need to do is take a break, step away, grab lunch, possibly even reset the code base back to earlier this morning. Take what I've learned and just make a smarter decision. I am certain there is a fix in here where I can basically get rid of the serifs, sharpen up some of the letters a bit, and immediately get a huge boost out of things. All right, very disappointing. Not where I wanted to end today. But yeah, so yeah, this will be the last stream for this week. And I'm not going to stream next week. Take a break. But yeah, my hope would be I may put out a video this week. We'll see. If I get things working today, I may put out like a normal YouTube video. But hopefully this means when I come back the week after next week, we are done with C++. I want to be done with it. I want quality above 90. I want performance below 10 seconds. Hopefully that happens this week. So we'll find out. Thank you for hanging with me, and chat soon.